G'day kids, and we're back for another video where 4D Bullshit Patrol here is going to learn you something. Now, this here is a swimming pool. I've googled images of swimming pools after swimming pool cover after a rainfall, and I've come up with this one. It's just one of many, and I'd like to point out how this relates to archaeology. It relates to geology of the planet that we live on. Now, let's get to the point. Imagine the water underneath this pool cover. The pool water itself is your Earth's magma. The cover is the Earth's crust, and the rainfall is our oceans. And that rainfall came about by a massive comet, which is made of water, reaching not making a big giant crater as it hit. No, it reaches, all the rings around the planets are formed by breakup of moons and whatnot, and it's called the Roche limit. Look it up, R-O-C. Oh, all right, I'll go and look it up for you, you lazy shits. Okay, here it is. Big body comes in within the gravitational field of a planet. And at some point, the planet's gravity completely nullifies its own limited gravity and breaks up and forms a ring around the planet, or falls on the planet as well. The Deluge, the skyfall, the flood myth from the Bible, Noah's flood. Whatever, choose your myth. Whether you're religious or not, there's something there that shows you that this big ass deluge happened, and here's how it happened. Giant comet filled our oceans. That's a Chinese myth too. The oceans are filled with comet water. That's what a Chinese friend of mine said. He researches this stuff. He's into aliens too, by the way. But anyway, that's beside the point. The point is, there is a reference to myths all over the place, whatever culture, of a massive deluge, and that's how it happened. Okay, now back to the point. So we've got our deluge, and it's fallen just like rain on top of this pool cover. Now, the point is that when this happens, the water will settle in the lowest points, forming a puddle, pushing that area of the pool cover down with the weight of that water. That means it's counted. Because, if you're going to push what is it? What's a good example of this for all those people who can't understand basic physics? Oh, that's a good example. Beanbag. Or a blow-up inflatable bed or something. It's only half full of air or something. You sit on it. You've just squished the air out of one end and popped it up in the other end. Okay? That's what's happening here. So we've got this big bubble formed in the middle where the weight of this water pushing down on this area of the pool cover has pushed it up in the middle. Now this is a really good example because it's pinned around the edges. The Earth is not pinned around the edges. It's just a continuous crust that goes around a sphere. There is no edge. So to have the same thing happen rather than just one big pool of water, and when the edges are pinned around, is kind of proof of how consistent this happens. Just like I said, sit on a beanbag, where your ass is goes down and the edges go up, and you can relax. So we've got this effect happening even here when the edges of the pool are pinned. Big bubble. Here's your continent, right? I'll stop rambling. Here's your continent in the middle, and here's your oceans. Now that means that when this was poking up and this was coming down, forming oceans, there was an enormous transfer of water from here, this area here, into this area here. Now we're going to prove that. So let's get into geology. Okay, Grand Canyon, perfect example. Here is the Colorado River. And they tell us that this Grand Canyon was carved out over millions and millions of years. As you know, you've all heard that, by the carving action of the Colorado River. So let's give it, this theory, as much let's extend an olive branch and see how we're doing. Okay, let's say, oh, all right, the Colorado River is running down here into this bend, and the centrifugal force here is carving out this bend, so it eats this away. And then maybe higher upstream here at this bend, it's carving out the other way. Eventually, this carvation action here, carving into this side, has now sent the path of the river over here, and this area here is carving out this way, and it's now carving out over here, and zigzagging over millions of years, carving out the canyon, and that's why the canyon is so wide for such a small river down the middle. Okay, and that river is not that small. You need that quantity of water to carve this over millions of years, apparently. Yeah. But if that was the case of a zigzag action of constant back and forth carvation across this canyon, then we'd end up with river flats in between. You can't have ridges like this. That ridge, let's say this river was once over here. This is not possible. If the river flowed, let's say, zigzagging around here, for example, then none of these ridges could exist. And you'd have flats in between. Wherever there was the river path previously, in between the two river paths would be a river flat. Okay, that's just math. Okay, if you don't get that, stop watching this video now and just get a t-shirt that says "I'm with stupid," because that is as basic physics as it gets. Okay, basic geology. River flats occur in areas where the river path once moved across from left to right. Okay. Now, so that's not possible. Not possible. There's no river flats here. It's just a big ass ravine. Okay, and additionally, this you could say, well, what about this was carved out by this little stream? Well, how did this little stream right here carve out as much ground as this giant river? Makes no sense whatsoever. Okay, and let's go upstream from this river. Okay, now this area here is a good example, actually. This area here, all right, this part of the stream here has just as much water as this part of the stream here. Yet, despite being made from the same rock, this area has decided over millions and millions of years to only erode maybe 10, 20 metres worth of rock. Whereas here, it's decided to erode multitudes of more rock, forming a much larger ravine. Why? It doesn't make any sense. And additionally, we've got, here's another one, example. Look, over millions of years, this part of the river here decided to erode just like, not much there, eh? And then it gets, I'm going to ride a bit more here because I feel like it. And, all right, here's another stream here. And then all of a sudden, it's decided that I'm going to erode hundreds or thousands of times more material with the same quantity of water as here. So that's just a basic lie. Again, if you don't understand what I'm trying to say here, go get a t-shirt that says "Stop watching immediately" and go get an "I'm with stupid" t-shirt. Now, we can scroll along and see that everywhere, and you can see this stream here. Now, this one's a real doozy because it has this stream here, right? And at the top where it would have started this erosion, oops, there is no stream at all. In fact, it's coming off of a higher area than the surrounding countryside. Here's the stream over here. What? Oh, but the stream moved across. Well, again, if the stream moved across from here, some ancient course that caused this ravine has now moved over to, I don't know, this ravine here, then none of this high country in between or this ridge can be possible. See that ridge there that I'm looking at really, really, really close up? That ridge is not possible. All of that would be carved out. See that? Perfect example right there. All of that would be carved out as the stream moved across from this spot to this spot. All right? It would be just like the river flat that doesn't exist on the main river as it carved left and right through this canyon. So that's a lie. The only way that this ravine, this canyon can happen is if this was pushing up like the bubble in the bloody pool as the oceans receded, okay? Or in this case, lower ground. This Rockies area pushed up, this area was lower. Google Maps is a good example. I like Google Maps as well as that one that was called National Map. And, go to the edge of a continent and you'll see the same thing, pretty much. An area of pool cover here, rising up, falling off the edge here. Pool covers don't have edges because they're made out of vinyl. They don't have ravines. But the earth crust is not made of vinyl, it's made of earth. So I'm going to go back to Australia, good example here. So it is made of dirt and rock apparently, and therefore it will cause erosion at the edge rather than consistent transfer from high to low country as in the pool cover, from bubble to puddle. So here we have our erosion. Here's a more deluge example. We've got our big floody here and it's moving across to the lower place here, just like on the pool cover, and the edges are getting carved out. There you go. That's how these canyons form. And I've just pointed out why it's a lie that it can't happen over millions and millions and millions of years. And pretty much that's it. It's busted. This millions of years of carvation in ravines theory does not stack up with basic geology, basic physics. Just like you don't need to be a mathematician to know that 2 plus 2 does not equal 5. If you say 2 plus 2 equals 4 and someone says, oh, but you're not a mathematician, that's called an ad hominem. They can't argue the fact that 2 plus 2 does not equal 4. Right? That's their position. That it doesn't. They can't argue, so they have to divert with what's called a straw man, argue something else. And one of the types of straw man out there is the ad hominem, which is attack your credentials to make that statement. It has nothing to do with the actual argument. That's what a straw man is. So that's one type of straw man. There's variations. I'll write a book one day, Sipes for Dummies. But for anyone with any common sense, you'll see that there was a deluge. And it's called the Roche limit and the swimming pool cover effect. Okay, and see you later.